Good morning. Today we are going to multiply and divide rational expressions. If you guys notice, we have rational expressions, so basically we have fractions that are multiplying, and within each of the fractions, the numerator is a polynomial and the denominator is a polynomial as well that we need to be able to factor completely, so then we can simplify and multiply it out. Let's go through example number one. On example number one, we are just simplifying the expressions. So we're not multiplying or dividing, we are just going to simplify. In order to be able to simplify this expression, we have a polynomial on top that we want to be able to factor. So let's go and deal with the top. We need to be able to factor the common term first. Some of you guys are tempted to just do the double parenthesis right away to factor it, but you want to be able to take out the common term. So ask yourself, is there a number that divides 3, 6, and 24? Yes, we can take out a 3. Do they all have an x? No. So we can only take out a 3. What's left? What do I need to multiply 3 to get 3x squared? It'll be x squared. What do I need to multiply 3 to get negative 6x? It'll be negative 2x. And 3 times 1 will be negative 24, it'll be negative 8. Now I can still factor this out. Whatever's inside the parentheses can still be factored out. So the 3 will stay outside. Now we can go and factor that out. So double parenthesis. Factors of x squared will be x and x. Factors of negative 8 are 8 and 1. 2 and 4, minus 2 and 4. I need to, when I multiply this out, I need to end up with a negative 2. So I make that a negative 4 and a positive 2. You want to be able to double check. So x times x is x squared. X times negative 4 is negative 4x. 2 times x will be positive 2x. When you add it, does it give you negative 2? Correct. Now let's go and deal with the denominator. I want to be able to factor out the common term first. So one number divides 2 and 32. I can take out 2. Do they both have an x? No. So I can just take out 2. 2 multiplied by 1 will give you 2x squared, will be x squared. 2 times 1 will give you negative 32, will be negative 16. Now I can still factor this out. Whatever's inside the parentheses is the difference of two squares. X squared is a square, 16 is a square, and there's a minus in between. So we have the 2 outside. Then we have double parentheses. Factors of x squared will be x and x. Factors of 16 will 4, 4, 1 negative, 1 positive. Now we can cancel out. We can cancel the x minus 4 and x minus 4. We can cancel that x, that's it actually. The x plus 4 doesn't cancel. We can now reduce our fraction, so we just have 3 and x plus 2, and then we have a 2 and an x plus 4. Now some of you guys are very tempted to cancel this 2 and 2. Remember, we are canceling the factors. So this is a factor, the 3 is a factor, the 2 is a factor, and the x plus 4 is a factor. So if there's a plus in between, you can't cancel it. So just be careful. This will be your answer. Let's continue with example B. We need to be able to simplify. So first, I'm going to go and factor the numerator. So is there a number that divides 2, 9, and 5? No. Do they all have an x? Yes. So I can go and take out 1x. What's left inside? What do I need to multiply x to get 2x to the third? Will be 2x squared. What do I need to multiply x to get negative 9x squared? Minus 9x. And x times y is negative 5x, will be minus 5. Denominator. If you guys notice, this is not written in the correct format. So we need to have to rewrite. The negative x should be written first. So it'll be negative x plus 5. That's a positive 5. So we just use the commutative property to rewrite it in the correct format. We can still factor this out, just like we did on the first problem. So x is outside. We're going to use our double parentheses to factor this out. Factors of 2x squared will be 2x and x. Factors of 5 will be 1 and 5. I need to end up with the negative 9, so I'm going to make my 5 here. I'm going to make that negative, so that's negative 10. And then my 1 here plus 1 will give me negative 9. On the denominator, I cannot have a negative number on the front. I want to be able to factor out a negative 1. Is there a number that divides 1 and 5? No. So I can just take out a negative 1. What do I need to multiply negative 1 to get negative x? X. Negative 1 times what is positive 5? Negative 5. Negative times negative is positive. Now I can cancel. That cancels out. And that's it. Do not cancel the 1. Remember, this is a factor. 2x plus 1 is a whole factor. You have to cancel the whole thing with the denominator. But we can't in this case. Now, the negative, I'm just going to move it up to the top. X divided by negative 1. So it'll be negative x, or negative 1x if you want, and multiply by 2x plus 1. So whenever you have a negative on the front, you can just move it to the top if you want, or to the middle, if you end up with a fraction. Let's continue with example number 2. On example number 2, it says, perform the indicator operations. And as you guys remember, back from elementary, to be able to multiply fractions, we want to be able to factor this out. A lot of you guys just say, okay, what number divides 15 and 25? What we actually are doing, you are factoring the 25 as 5 times 5, the 15 as 3 times 5, the 6 as 3 times 2, and the 4 as 2 times 2. And then from there we can cancel the 5s, we can cancel one of the 2s. So we have left 3 times 3 is 9, 5 times 2 is 10. So we're going to use that process to be able to simplify on example number 2. So whenever it's multiplying, we want to be able to factor the top and the bottom, factor the top and the bottom, and then see what cancels. So let's go and deal with the x squared minus 4 first. That's the difference of two squares. First, you want to be able to say, is there a number that divides 1 and 4? No. And we know that this is the difference of two squares. X squared is a square, 4 is a square, and there's a minus in between. So I can just do my double parentheses. Factors of x squared will be x and x. Factors of 4 will be 2 and 2, 1 negative, and 1 positive. Let's continue with the denominator. Self, so ask yourself, self, one number divides 2, that also divides 6. I can take out 2. Do they both have an x? No. So what do I need to multiply 2 to get 2x? X. 2 times what is positive 6? Positive 3. Now we're going to multiply. We want to be able to factor this now. So we need to take out the common factor first. Is there a number that divides 1, 4, and 3? No. Do they all have an x? No. Nothing to factor out. So we can just do the double parenthesis. What are the factors of x squared? Will be x and x. Factors of 3 will be 3 and 1. And they both should be positive to end up with a 4. So 1x plus 3x will be total of 4. If you guys notice, same as we have on example number 1, this is not written correctly. We want to be able to rewrite the negative x first. So it'll be negative x and then the positive 4. We want to be able to factor out a negative number from here. And I usually just write it down underneath just to be able to save some space. So, is there a number that divides 1 and 4? No. But I want to be able to factor a negative 1 to make the x positive. Negative 1 times what is negative x? X. Negative 1 times what is positive 4? Negative 4. Now I can cancel out. Let's see. What cancels? X plus 3 cancels. And that's it. You guys will notice that sometimes everything cancels, and there's sometimes that only one item cancels, which is fine. Now you don't need to multiply it out, you can just leave it as it is. So we have x minus 2, we have x plus 2, and we also have an x plus 1 on top. On the denominator we have 2 times negative 1 is negative 2, and then we still have a x minus 4. Now many times you guys will see this negative will be transferred to the middle. If there's just a negative number on the bottom, it will just be transferred here, which is fine. So this will be your final answer. If you leave the negative on the denominator, I still give you full credit, but you need to be able to recognize that there are times that they're going to place it in the middle as the negative for the whole fraction. Let's go with example 2b. Go and pause it, see if you guys can work it out by yourselves, and then we can work it out together afterwards. Go and pause it. Great. So for example B, we have a multiplication, so we just need to be able to factor the top, the bottom, factor the top, factor the bottom, and then just see what cancels. Let's see, from the top, taking the common factor, is there a number that divides 5, 23, and 12? No. Do they all have an x? No. So I can just try to factor by using my double parentheses. Factors of 5x squared will be 5x and x. Factors of 12 are 6 and 2. I need to end up with a negative 23. That's a positive 12, so they both should have the same sign. In this case, they both should be negative. So I'm going to use 4 and 3. I'm going to use my 4 here, so that's 20, and my 3 here, so that's 3. And I'm going to make them both negative. On the denominator, we have x squared minus 16. If you guys notice, nothing I can take out. There's no common factor. So I can just do my double parentheses. That's the difference of two squares. X squared is a square, 16 is a square. There's a minus in between. So factors of x squared will be x and x. Factors of 16 will be 4 and 4. And 1 negative and 1 positive. Multiply by. You want to be able to factor the top. So factor the common term first. Is there a number that divides 3 that also divides 12? 3. Do they both have an x? Yes. So I can take out a 3x. 3x times what is 3x squared? X. 3x times what is positive 12? Will be positive 4. Denominator. Let's go and try to see if we can take out a common factor. Is there a number that divides 5 and 3? No. Do they both have an x? No. Only two terms, so we can just leave as this. Nothing to factor out. And now we can cancel out the common terms. Let's see. We have x plus 4 here. X minus 4 here. 5x minus 3. So the only thing that we have left is a 3x as our answer. If you guys notice, there are times that everything cancels, as here. There are times that only one item cancels, or one factor cancels, which is fine.